You found your way into part 2 of the Geometry First Semester Final Review. We already went through 1 through 16, so let's keep going and look at number 17, which says name the property illustrated. So we have if x equals y and y equals z, then x equals z. If I rewrote this kind of together here, I can see that because both x and z are equal to y, then they're going to be equal to each other. And when we have this, this is a property we call transitive property. If both of them equal y, they equal each other. In number 18, we need to name the property we have. So we start with a plus b equals 80, and we know that b is 80, and we've suddenly replaced the b with the 50. I should say b equals 50. We've replaced it with that. By replacing it, we've done substitution. On number 19, 2 and 8, if we mark them here, and looking at our angle types. Well, we know it's not alternate exterior because they're not on opposite sides. 2 and 7 would be alternate exterior, and 1 and 8 would be alternate exterior. They're not interior, so they're not alternate interior. They're not corresponding because they're not in the same location. 2 and 6 would be corresponding, and 4 and 8 would be corresponding. But the fact that we could move 2 down to where 6 is, and those two would be a linear pair, which means they're supplementary, we're going to go with the answer of supplementary. Number 20, which angles are congruent? So we're really looking here at 3, 1, and 5 are all the same because 1 and 3 are corresponding, 3 and 5 are vertical, and 1 and 5 are alternate exterior. So we could say 1 and 5 are congruent. Now you also could have technically said 2 and 4 are congruent because those are vertical as well, but well, that wasn't one of our options. For number 21, if we look at the properties that we have, we need to find what's going on in number 2. So we're saying 1 and 2 add up to be AOC. So these parts add up to be the bigger angle. The same thing happens with 2 and 3. They add up to be BOD. So I'm adding up the angles, the smaller angle pieces, to equal the whole thing. We're going to call that the angle addition postulate. For number 22, we know that angle 1 is 110 degrees. We need to find the other values. Now, we can actually go through and fill everything in. I know that angle 4 is also 110, angle 5 is 110, and angle 8 is 110. Because I have 1 and 4 vertical, 1 and 5 are corresponding, 5 and 8 are vertical. They work through all the ways. That means all of the other angles there would be 70 degrees. So now it's just going through and pretty much matching which one fits. I got angle 7 at 110, that's not going to work. Angle 5 at 110, that one is, so we're going to go with the answer of D. Number 23, which will prove that lines are parallel. 2 and 7 are not the same angle. Those would be exterior on the same side. That doesn't work. 3 and 6 are consecutive interior. Those are actually supplementary for the lines to be parallel, not congruent. That's out. 2 and 5, they're not one of our pairs. But 1 and 7 are alternate exterior, so those would make the lines parallel. In number 24, which statement is correct? So let's see. I have 2 and 11. We'll start here. 2 and 11. Well, I can go from 2 to 4 matching. I can go from 4 to 12 matching, but that doesn't match up with 11. So that one's going to be out. Let's look at 12 and 9. Let's see if that one works. 12, I can go from 12 to 14, 14 to 16, 16 to 10. Those match up. They're not going to match up to 9. So that one's out. How about 4 to 11? Well, let's see. 4 I can sit at 12. But now if 4 and 12 are the same, and 11 and 12 add up to 180, that one's actually going to work for us. That one's going to be supplementary. It's a linear pair. If I looked at 15 and 11, just to check, here's 11. I can go from 11 to 10. Try again. 11 to 9 would be corresponding. 9 to 15 would be vertical, so actually this one would have to be equal, not supplementary, so that's why that one is out. We'd go with the answer of B. Number 25. I notice I have these parallel lines here, so that means that this angle together and the 88 are actually supplementary, they add up to 180. You could also think of this as having consecutive interior angles. So 88 plus 2x plus 36 equals 180. Let's check what 88 and 36 is. We get 124 plus 2x equals 180. Subtract 124 from 180. We get 56 equals 2x. So x comes out to be 28. In number 26, we need to find angle y. Well, a few ways we could get to it. If I know those 30 and 50 adds up to 80, that means my other angle here would be 100 because it has to add to 180. I also have 50 and this angle are corresponding, so that would also be 50. I also have the 30 and this angle would be alternate interior, so that would be 30. Now by using that, I can see that the y is vertical to the 30 and 100, or it's a linear pair to the 50. In either case, I could do 50 from 180 and get 130, or just add the 100 and the 30 and get 130. All right, we already did that one. On to 27. Which type of triangle has two angles that measure 30 degrees? So let's draw here. We got 30, 30. Now it's not to scale, but it gives us an idea. Maybe we can find another piece. 30 and 30 is 60. That leaves me with 120 degrees. 120 degrees is an obtuse angle. That means there'll be an obtuse triangle. Now, it wouldn't necessarily be scalene. It would actually be isosceles because the two angles match the 30 degrees. So that means the opposite sides would also match. An acute angle has to have all angles less than 90, and an equilateral would have all angles the same, which means they'd have to be 60 degrees. For number 28, which is an acute isosceles triangle? Well, let's get the isosceles out of the way. We need to make sure two sides are the same. If that's the case, B is gone. And then if it needs to be acute, all the angles have to be less than 90, meaning we can't have a right angle. The A is gone. And we can't have an obtuse angle. C is gone. Now, even though they gave me the 30, I can see that the other two angles would also be 30 and then eventually 120. So that's obtuse. D is going to be our best choice. In number 29, we have a slope of LM is negative 2/3. We know it's perpendicular here to MP. So whenever we have slopes and we need to find the perpendicular slope to it, they're opposite reciprocals. So I'm going to change the sign, make it positive, take the reciprocal, it becomes 3/2. So it's positive 3/2 is our answer. You could also check because if you multiply two perpendicular slopes, they come out to be -1, which this one would end up being. On number 30, we need to find the measure of angle A. So I'm going to say 3x plus 4x plus 5x equals 180. That comes out to be 12x equals 180. And x is 15. But that's not what they're looking for. They want us to find angle A. I'm going to plug 15 in, and I get 45 degrees. Number 31, I need to find the value of x. Well, since I have an isosceles triangle, I also know that's 70. Now, an exterior angle, x, is the sum of the two interior angles not next to it, or 70 plus 70, which would be 140. If you didn't see that, though, you could find the other angle in that triangle, which would have to be 40, because 70 plus 70 is 40. Subtracted from 180 leaves me 40 left over. And then, of course, the angle next to that would be the 140 because they'd be a linear pair. Okay, number 32, we need to find the measure of angle BAD, and that's the one out here. We just talked about an exterior angle. We're going to do the same idea here. This angle out here is going to be 42 plus 90, which will be 132. Exterior angle is equal to the sum of the interiors, non-adjacent interiors, we should say. And 33, this will be the last one on this part. I can get a vertical angle for 40, puts that in here. Then I could add the 40 and the 60 to get to the exterior, which is y, but maybe we didn't see that one. I could find the other angle in that triangle, which would be 80, because 40 plus 60 is 100. Subtract that from 180, I have 80 left over. which is going to make y 100 because it's a linear pair and next to it.